All right, welcome back. So today we are going to be starting a new conversation involving exponents. And today we are going to be talking about what are called integer exponents. So it brings together a couple of different ideas. We're talking about integer exponents, not fractional exponents. So these exponents that we are going to be discussing are either positive whole numbers or negative whole numbers. Eventually, we are going to be talking about what it means to be a fractional exponent, but today it's a quick little introduction as to what an integer exponent is. So without further ado, let's begin. Let's think back to what we know about exponents, and let's remember that 2 raised to the third power means 2 times 2 times 2. The base of this example is 2, that's the bigger number, and the exponent is positive 3. That is the tiny number. Exponents can also be 0 or they can be negative. So within here, there are 3 different general examples. We have a situation where we have 0 exponents, negative exponents, and negative exponents in the denominator. Let's first look at the 0 exponents. So by definition, for any non-zero number, x can be any number as long as it is not 0. If if x is raised to the 0th power, it will equal 1. Some examples below: 6 raised to the 0 is equal to 1. 1/2 raised to the 0 is also equal to 1. We also have negative exponents. So by definition, for any non-zero number, x, and any integer, n, x raised to the negative nth power turns into 1 divided by x to the nth power. So essentially what happens there is if we have a negative exponent, wherever that base and exponent together are, we call it the power. Wherever the power is in the fraction, it switches. If it's in the numerator, it goes into the denominator. If it's in the denominator, it goes into the numerator. So some examples are 5 raised to the negative third is equal to 1 over 5 to the positive third. And 2 to the negative fourth is equal to 1 over 2 to the positive fourth. Now, going back to what I was just saying with regards to negative exponents, we can have negative exponents in the denominator. For any non-zero number x and any integer n, if we have 1 divided by x to the negative nth power, that's equal to x to the nth. So again, in this example, the exponent that's negative, that power is in the denominator. So if we wanted to change it into a positive exponent, we shift it into the numerator. And technically here, x to the n is technically over 1. Likewise, over in the negative exponent, x to the negative n is over 1. If it's a number without a fraction, it is in the numerator, just the denominator is 1. So wherever it is, it switches locations within the fractions. 0 to the 0th and 0 to the negative nth are what we call undefined. We are going to be talking about that a little bit more later in class. Let's go through a couple of examples that are on your guide notes, but let's walk through them together. Let's say we want to simplify 4 to the negative second. Well, we have a negative exponent. So what we can do is we can write it without negative exponents. We take 4 to the negative second, that was in the numerator, we bring it into the denominator. So now we have 1 divided by 4 squared, or 4 to the second. We can write it in expanded form, so 4 times 4, and we get 16. So we get 1 over 16. You can jump a step from 4 squared and go down to 16. That's completely fine. But what if we had something that looked like this? On the right-hand side of your guide notes, we have x squared times y to the negative third times z to the 0th. Well, we're going to write it without having negative exponents. Right now we have a y to the negative third in the numerator, so we're going to write it in the denominator. So I have x squared times z to the 0th, all divided by y to the third. Again, it was a negative exponent in the numerator. We bring it down to the denominator, and now it's a positive exponent. Now we're going to simplify because we know that any integer raised to the 0th power is 1. So z, the 0th turns into 1. So now we have x squared times 1 over y to the 3rd, or y cubed, and we can simplify and we get x squared divided by y to the 3rd. So by knowing these properties, we're able to simplify a lot of these, what some students think of scary expressions, and we can use our properties of exponents to help us simplify and turn them into a much nicer setting. So with that, please work on problems 1 through 9 on the guided notes and resume when you're ready to move forward. All right, kiddos. So let's evaluate a to the negative 3rd times b to the 4th when a is equal to 5 and b is equal to 2. What we are going to do is we are going to substitute these values in first. So a becomes 5 and b becomes 2. From here, we can write without the use of negative exponents because 5 to the negative 3rd is a negative exponent. We'd have 2 over 2 to the 4th, divided by 5 to the 3rd. And now we can simplify this down and we get 16 divided by 125, and we cannot simplify that down, so that is going to be the answer. And when evaluating, it is important to determine whether the negative is raised to the power. So with this, let's go through a couple more examples. Let's say we want to evaluate negative x to the negative 2nd for x being equal to 10. What you're going to notice is the negative is not raised to the power. It's not raised to it because it's the opposite of x to the negative 2nd. It is not getting raised to the power. So what we can do is, again, we are going to substitute. X is 10, so it becomes the opposite, or negative 10 to the negative 2nd. We can rewrite without negative exponents, and we get negative 1 over 100. Now, here is the major difference. On the right-hand side, visually, there is a difference, and it is subtle, but it is very important. On the right-hand side, we have in parentheses the opposite of x. All of that getting raised to the negative 2nd power. Where on the left-hand side, we only had the opposite of x getting raised to the negative 2nd. The exponent on the left was only attached to the variable. It was only attached to the variable. On the right-hand side, all of this is together. Like High School Musical, we're all in this together. That's okay. Before your time. So since the exponent is attached to the entire value inside the parentheses, we have to approach it slightly different because the negative is raised to this power. So when we substitute, it's going to turn into negative 10 all raised to the negative 2nd power. We can write without the use of negative exponents, so we get 1 over negative 10 squared. And now we think, okay, well, negative 10 squared, that's negative 10 times negative 10. And we know a negative times a negative is a positive. So in this answer, we get 1 over 100. And it was all because the subtle differences with the negative sign with our variable. If it is included within the set of parentheses, everything inside the set of parentheses is getting raised to that exponent, like it was on the right-hand side. But on the left-hand side, it was the negative sign and then the variable or the value getting raised to the exponent. And the exponent is only attached to the variable x in our case. So please be mindful and be super duper careful when you are evaluating with exponents, because you need to analyze and be ready to identify when and when not to include the negative sign. But so far, y'all are rock stars. Keep up the great work. With this, please work on problems 10 through 15 on the guided notes. Please let me know if you have any questions, and I will talk to you soon. Have a good one.